welcome to Essential Fundamentals to Multiplayer Talk. All right, so first of all, we're AQ GDC. I'm sure all of you guys know AQ Game Development Club, and we are here with John Tang. Special thanks to John Tang for being our main speaker for this talk. So give him a round of applause. So without further ado, I'll pass the mic to John and let him do his thing. So John. Hello people, I've been told to do my thing. Oh. Wait, I just realized that I can hold my phone and my computer at the same time. It's gonna help figure it out. Right. So thank you, Azar. And hello people. This is a size no good amount. Thank you for everyone coming. And just before we begin, this is basically essential fundamentals of multiplayer implementations. So it's just basically all my years of knowledge. I'm just gonna try to cram it all in these 2 hours. Honestly, try to cram it all into your heads and hopefully incubate some multiplayer engineers out of this. So thank you for ADU for giving me this opportunity. And without further ado, I will begin. So first of all, I want to introduce myself first. Wait. What over there? I put it the right one. Well, hi. So basically, I'm John Tang. You can call me Johnson, but that'll be weird, so just call me John. I just want to give a very quick portfolio. Is that I did AAA open world multiplayer before. It's unnamed, and I can't share much more about that. But basically, that's my biggest experience there doing multiplayer. I did like a Clash of Clans type multiplayer as well, and unfortunately, that is Web3. But that means I'm pretty good at knowing how to secure transactions between players. And my FYP is in multiplayer, which I was a finalist for CGame Awards. Right. So in this talk, I'm gonna, of course, talk about multiplayer, but I'm gonna be cramping a lot of information to you guys. So at any point of time, if you guys have any questions, I'm sure we have a manageable amount here. Just raise your hand and we just ask the question now, right now, right then. So, oh yeah, forgive me if I cough or feel a little bit slow today with my voice because I just recovered from a sickness. So I'm gonna try my best. Yeah, I think it would. So the first question I want to set to everyone right here. So how many types of multiplayer frameworks are there? Do you guys know? Yes. 1, 2, 3. That. Going twice. Well, we look through the slide. So this is a trick question because a lot of people will talk about how many frameworks are there. Well, people talk about better frameworks and stuff and all. But technically, I want you guys to just know multiplayer is actually really, really simple. There's only one framework, which is very simple. There's only one. It's always a relationship between a client and a server without doubt, unless quantum physics has fully developed into a whole new computer science program, you just need to know that clients and servers, there's only ever one connection between the player and a server. There must always be a server and there must always be a client. This is the fundamental basics of multiplayer. So now the better one is how many types of multiplayer connections are there? None. Don't forget about LAN, right? That's a good one. What? Four? Four? Four. Come on, give me examples. Sorry? P2P, peer-to-peer. Any more? Dedicated server. Yes. Distributed authority. Not really, but good try. Any more? Okay, so I'll move on first. Of course, the first and foremost is dedicated online servers. This is the online games that everyone knows about. You have a server, you have a client. What's more to know? It's basically you connect to a server sends you back data, and that's about it. I don't even include any examples. There's just way too many to talk about. Next is the local multiplayer. This is a multiplayer that a lot of people don't talk about because you're just only using one PC. This is a split screen multiplayer people talk about, and you can still see in some games, and especially in Nintendo Switch games, right? So you see that there's no server here. Technically, this is false because the computer is a server. But you don't need it to be a separate thing because the computer itself, the game itself, is the server itself. Just think about that. LAN parties. LAN stands for local area network. It's also a multiplayer, but it's separate from the dedicated online server because it's technically not online. It's offline. So you see this bubble over here? That's the bubble you don't break through, which is the internet. Because everyone connects to one local server and never goes beyond that. So technically, you don't need Wi-Fi to join it. You don't need internet. Yeah, that's about it. So also a multiplayer. Some games still support this, but mostly this is starting to not be any case anymore. Peer-to-peer. Now, this is a lot of people know this, but look at this diagram, right? So everyone is its own server. This is a very special case. Peer-to-peer themselves are servers themselves. They actually pass information to each other, so they manage their own information, their own data, which is very, very obvious, very, very commonly, commonly equalized to or compared to, or even misnomer to what current games are is listen server system. So peer-to-peer is not listen server because a listen server is when a client is the server themselves and everyone else connects to that client. A peer-to-peer is not. So if you see in this diagram, I can see the related. All right. So in this diagram, only one server exists, but peer-to-peer has multiple servers. This is very important if you guys are going to create an actual peer-to-peer system because you guys need to know what peer-to-peer does. So every method has its own benefit, right? It serves different purposes and it gives different solutions to different problems, but it also always brings different weaknesses to your entire system. So you must know what you want to design first before actually moving on. So starting out, when you start a project, you need to know what kind of game you're making. So I wanted to add this one here, network topologies by Unity themselves, actually, because this is actually a really good reference. They just break it down very, very simple. So you can kind of check it out what network topologies are on your free time. Yes. I'm actually going to this line because I don't really know what my slides are. All right, so yeah, the reason why servers exist is because server is actually just another instance of the game that holds the proper data of how a game works. Okay, it's the point where it stores the data. It tells people, okay, you have this data, you have that data, and I have that data. Hi, welcome. So yes, the player gives this player input or whatever information you send, you give it to the server will give it, why did I keep finding this? The server gives back the state of the game, the data of the game back to the player. So by design, they actually control the final result of what players sees, what players do, and what the entire thing is going to be. So yes, go ahead.
Why didn't the games actually that you downloaded have way so much? Like the games that you actually download way too much if all the info is on the server. Technically, you're just sending in the inputs. Why do you need all the assets and textures and stuff like that?
It's a very good question. So assets and anything visual doesn't need to be sent to the server. So imagine you are playing a Call of Duty game, notoriously 200 gigs of bloatware. Imagine that you need, so each character themselves is a few megabytes already of data. If you're sending that to the server, are you sure that you can run 100 megabytes every frame? The thing is, the magic of multiplayer is that you need to think in a very different way, in the sense that you're actually setting what is absolutely necessary. Everything else does not matter. What you actually need in a multiplayer game, it's not the player's model. You can have them download that because nothing's going to change, right? What actually changes is, for example, their location, how they move, right? That is what needs to be actually synchronized, not their models, not their skins. All of this can be done through another method. So as a multiplayer engineer, you first must think what needs to be sent and what absolutely does not need to be sent. Network optimization is really, really important with more slides coming on later. Right, so the first rule of multiplayer cloud, I'd like you guys to remember this is never ever trust the client. Right? So all those things, you anyone work in retail here? Good, and I hope you guys never do. Right? You walk in, the customer says, I'm always right. But no, in multiplayer, you say they're always wrong because they are. You never ever trust a client because clients basically means every computer that plays the game, every player. If you trust them, they can change the state of your game. So you must think customers, they know exactly nothing what they want. So that means that nothing you send to them should be ever sent back except for their input. I say input doesn't mean they want. They are basically requesting for change. Does not mean you approve that change. It's just them asking for a change. The client itself cannot be trusted in the sense that if you pass a secret, important data that allows them to change it, that means you give them the key to change your game. You guys ever seen hackers online? This is why hacks can happen. Because they gave data to the player and the player did something with it. So here's a thing, a thought to think about. How do people wall hack? Why does wall hacks exist?
Because the server gives too much information to the client, and in that, sometimes the player position is exposed.
Mm-hmm.
So if the player position is exposed, I'm assuming, I'm not a multiplayer engineer, but I'm assuming if the player position is easily accessible by a client, if someone was no live and they're snooping to the server, obviously, yeah. I would assume all they have to do is just write the simple program on their computer and just spot the closest player position, right?
Okay.
I'm not sure, but that's my theory.
It's a good one. So as a programmer, how do you make sure that your player can know where the player is without seeing where they are?
I guess optimization.
Literally. Well, to the people here, technically that is a trick question because there's no solution. Because there's so many instances, like just think of a Call of Duty game. You're running through the streets, you're running through buildings, right? How would you know that the player should be able to see that player? Unless you have a quantum computer as a server, there is just too much data for you to calculate every player from every possible field of view for every frame to know if a player can see that. So technically, why Call of Duty can't really fix wall hacks? Because the client itself, has no choice but to know that the client is there because you can't determine if the player can see or cannot see that other player. So all it takes is just one person to break the program and say, I want to highlight, change the model everyone with a different color, just tell me where they are. This is a design paradox because you can't really solve this. The only way you can technically solve it at this moment is to make sure that, okay, their patterns are not corresponding to human behavior or what they can see or whatnot. So I will give another example, which is World of Tanks. It's technically one of the games I played that smartly integrates on what you can see and what you cannot see. Is you actually literally cannot see the model of the tank. They don't have wall hacks. They can't get wall hacks because you can only see the tank if your crew sees the tank. So the entire mechanic of the game is they actually offloaded the entire spawning mechanic into a game mechanic that your crew, your commander has to be able to physically see that tank to only see for you to only show up on the game. So the wall hacks in that game actually don't allow you, there's no wall hacks for that game, but it actually only tracks bullet trails, which is a visual effect that is done only on the client side. That is the closest I've been to. So yes, I will now go into connecting data. How do we synchronize games? So games have a lot of data to process. I'll be talking about like blah blah blah. You need to talk about it. And this gentleman here gave a very good question. So I'm just gonna ask a very simple question. What are the data that's synced in this short gif? Player position.
Movement, acceleration.
Mm.
And damage.
Player damage.
Inputs. GAP.
Sorry.
GAP.
Player team. Yes.
Health.
Health. Yes.
Bullets or the like.
Bullets.
Gun.
Yes. Trajectory.
Trajectory.
Any more?
Also the jump.
Sure. The jump. The grapple. Velocity.
The build. The stair. It's
Yeah. There's that.
the stairs.
The stairs. Yes. Hit scan, which is a bullet thing, basically. So yes, all these answers are, I guess, based on their design, they are correct. So I'm gonna give a few examples of what I can already see here. Is this bunch of stuff, and each of them, I try to put like data that is needed to synchronize each frame, but not all of them needs to be synchronized each frame. So in that example, you already have this bunch of stuff. So to think about the scale of multiplayer, we have to think in. Wait, how do we see this data? Oh yeah, sorry, I forgot my slide. My slides are ordered. So let me retrace my steps. Before I got to that part, how do we sync this data in the first place? And that is through a keyword called replication. So if you ever see my slides of this red text, those are words that I kind of want you guys to remember because you will, when in your journey to make multiplayer, you will see this over and over again. Maybe in different words, but they kind of mean the same thing as a concept essentially. So remote procedural calls is known as RPC as well. And technically in multiplayer or the current state of multiplayer, a lot of things are run through what we call RPCs. So I'm going to talk about replication itself. Replication in the concept is it just means the synchronization of data. It just means that the server says X equals 5. That means client A has to know X equals 5, client B knows X equals 5, client C is X equals 5, and so on and so forth. Replication just means that for this one data to be this state, everyone else must recognize that this data is this state. That is just called replication. So by using RPCs, we do majorly two ways of synchronization of data, which is usually variables and functions. However, variables is kind of just functions, but it's automated, much more simple. It's just changing one variable into something else. So variables here are just what I mentioned just now, X equals 5. When I said X equals 4, the server side says X equals 4. That means client A has to acknowledge that X turns into 4, client B turns into X into 4, and so on and so forth. Whereas functions is the replication of logic. This is where logic is going to happen for multiplayer. This is where you need to know that, okay, if player is here, whatnot, I need to send this player, and the player has to take this synchronized action to realize what they need to do on their client side. So for some examples like this is player actions. So maybe I throw a grenade and player input, right? When I send it to the server has to go through an RPC function to know, number one, they're replicating an action. Number two, they need to understand what the consequence of this action is. Number three, they need to tell everyone what this consequence is. So if I throw a grenade, the server calculates the trajectory. They need to send that trajectory to every client and then make sure that grenade explodes after a certain amount of time. That is a replicator function. Right. So this is an example of how it does, how remote procedural call will happen. So either a client or a server would do a remote call, and the server themselves can do a remote procedural call. They request the replicator change, which the server requests it sends back to itself. The server basically determines what we call authority and ownership. This is also something that's going to be very, very important coming on. and executes a synchronization function. Judging that no one actually commented on the obvious flaws here, I think I'm too late on this word. I had to ask to get that reaction now. But yes, it's okay. It's okay. I'm not gonna push it further. It's cringy now. It's lost. If you get it, you'll get it. But wait. Okay. So if everyone asks for a change, what would exactly happen? Let's say client A says, "Hey, I want X to equal to 3," and B says, "I want X equal to 5." What happens? Sorry? Overlap, yes. So how do we solve this overlap? The concept of just now what I mentioned. The second rule is that you must absolutely understand authority and ownership. No, this is not a BDSM relationship. It's about who owns the permissions to change game data and who owns the permissions to request or change. Yes.
So let's say there's two players, right?
Yes.
One player sends the data that he's moving in one direction, but at the same time, the second player is moving the player. So he's intercepting with the position of the first player. Which one will the server actually get first?
That is a very, very good question. Now, since that I have absolutely no memory of what my next slide is, let me just go to the next slide first. Okay, I'll just leave this on. I'll answer your question. So it's a very interesting question because you break it down. It's actually just two very simple questions. Who owns the location of the player? Who owns the movement of the player? Yeah, that's yeah, two, correct. So
Yeah.
my question is that who owns an ownership? Who owns the permission to change the location of the player?
Technically, any player that moves the other player.
Incorrect. The person, the thing that owns the ability to ask for change of the player location is the game itself, the server itself. What the player actually owns, the only thing they own is their input. That's why I'm actually hinting foreshadowing. Input, input, input. The player is requesting for change of their direction of where they're going, but the server calculates where they will end up to be.
Oh,
Yeah.
Now I get it now.
Yeah. So in your example, yeah. So in your example, what the player actually does is that he moves in one direction. William Page. But the server itself has both the location of the players. Now the player wants to go this way, and this player is already blocking this player. The server actually tells back to the player and says, "Hey, nothing changes. Your location can't move. You have given a request of change of the direction of the player, but the location never is changed." In this example, ownership of your location belongs to the server, and the ownership of the player action belongs to the player. Now, one thing I want to point out in this scenario as well is authority. Authority means who decides to have that change, who decides to execute this change. So in my example, with ownership and whatnot, only the server can decide whether all of this ever actually happens. So even if the player says, "I want to move this way," only person who can actually execute this change is the server, the authority of the figure of authority in this entire scenario. So think about it, what you like, but this is a very complicated diagram when you get to multiplayer and massively multiplayer online. But if it helps you think better, just think of it like a BDSM relationship. Very easy. So, moving on. Here's a quick diagram sketched out. So it's very easy. The player itself who has ownership on their the change they want to send, they send a request to the server who has the authority, which verifies the transaction, which is what the authoritative figure will do. And if only approved, commits the change and notifies the change. Replication. It's just the entire multiplayer framework of everything runs this single business. Yes. Yes, good question. So does this happen every second? It has to. Depends on what game you're making. Making an FPS game, we don't have no choice because everyone's moving. You need to have that change there, right? You have to see where. Making a turn-based game, do you really need to? You don't really need to see what everyone else is doing, unless you have a certain mechanic that you need to. But nowadays, most games actually just kind of replicate every frame because it helps you expand a feature, but that's something you should research for yourself. So depending on the use case, it doesn't have to happen every second, but you need to know what you need for your game. Yes. So that's why in a peer-to-peer scenario, everyone has partial ownership and partial authority of the game, which means a very, very big problem. That means in a peer-to-peer game, your friends can cheat and affect you, and you can cheat and affect them. No one has, basically, no one has to have the biggest say until someone takes another player out. So this is basically a decentralized system. It might be communism, whatever it is like this. So this is why games nowadays don't ever actually use peer-to-peer. Because if one player cheats, the player can ruin the game for everyone else.
That's what involved in service.
Yeah, so if you think like older games, if you see why people can cheat and they can affect you, and you think, what the hell, what's going on? This is why peer-to-peer. Which is why it's like really dropped down right now, and we're going for this service nowadays. Okay. So talking about bandwidth, okay. So where I was trying to go with just now is bandwidth and network budget. So in that example, remember this, Jeff? We have a lot of data to sync. Now I'm gonna give you a very simple breakdown of how much data we need to sync here. So let's say we sync one frame of movement input of a single player. Very simple. Vector, variable. We do it like a vector tree, which means there's 3 floats, which means one float is 4 bytes. Therefore, vector variables, 12 bytes. One frame, 12 bytes. Pretty small. Not too bad. Now, when you crunch the numbers, boom, 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 and this is just a few. This is what I call 10% example. This is what happens at 10% of what a frame is to synchronize. You get 132 beats. Bytes. Actually, bytes. Should be bytes. Yes. So if we reverse calculate that, blah 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 blah, you have 792 KD. I think in my fever, I do not know what I make here, but oh yeah, I remember now. Sorry. So 7 megabytes you need for every second, or 63.36 MB, which is what internet resellers, the sellers, internet service provider would like to tell you. They actually use a small b. This is bit, not bytes, which means it's 8 times bigger than this. So I'm not sure if you guys are old enough, but there were days where this is impossible because my house was only at 10 MB. So if you guys were from those days, imagine a modern Fortnite game. You need 6 times that bandwidth. This is not inclusive of your family members using the internet. Someone watching stuff. Exactly. Exactly. So if you guys ever experience lag playing games or someone is watching stuff, it's because you're fighting over bandwidth. So it is absolutely very, very important to know how to design your data to save your bandwidth. So I'm going to move into optimizing bandwidth now. This is technical. Oh, sorry.
And what is the big mean as like in
Ping latency. So I will get to it on one of the slides. I think when I build the structure, when I show you the structures.
So while we're like near on the topic of like server authority, stuff like that,
Yes.
my question is for like bigger scale games where you don't use peer to peer. Do you prefer server authoritative movement or client authoritative movement?
I would say it depends on the game, but when you build PvP games, basically player versus player, you need to establish a very, very fair scenario. That means you cannot trust every player because there are going to be bad actors who wants to use cheats to get an unfair advantage of the game. But some games they use flying authoritative movements or whatnot. It's because they're making a PvE game. They can let the clients mess around because well, it kind of ruins the experience, but because the clients choose to, they're playing with friends most likely, and they just, okay, like you're playing with people with cheat. If that, you're okay with that, and you're okay with that. So it also comes out in game design. Do you really need that? You really need to sync that movement. So it's a trade-off.
What about like a client authoritative movement, but with like server, like the server has to like approve, then like send it back.
That's not client authoritative.
Hmm?
It's not client
Yeah,
authoritative.
but it's not fully server authoritative either. It's like
No,
the
only
client like moves, but then the server checks after. The server doesn't have the authority to move the person itself.
Okay, I get what you're saying. It's basically a method called extrapolation or interpolation prediction. But I'll get to this very end of my slides. It's what you're experiencing. But technically, in authoritative systems, there can only be one of these, either server or the client, can only execute the chain. So what you're seeing, I will explain to you later. That's all right.
All right, thank you.
Yes. Good question though. Thank you for that. So yes, I hope you got it. But optimizing bandwidth. So this might be a little bit advanced. I hope you guys can try this in, but bandwidth can be really, really important. When you're starting out, you can blame that on your boss. You can try to design something that's good, but unless you're making a triple A game with billions of players, you don't usually need to deal with this. But to think about it, I'm just gonna brief you guys because it's a fundamental thing that you guys should know about. And the most important thing is that there's something here called UDP and TCP. Anyone here that is that studies cybersecurity or network? I forgot your computer science. Heard of it before? You know what it is? Right. So you wanna explain?
It's basically a core application share where it transit data into packets, then into frame, and then it basically makes it easy to send and receive the data.
Okay. So what's the significance of games?
Games basically turns the data into packets, then first, sorry, turns it into segments, then frames, then into packets, and then it sends it, and then the server receives it and it converts it into databases by using the process.
Okay. So I'm gonna speed it up here, but basically, UDP and TCP serves two very important roles, which is one is reliable. TCP is reliable. This is the people you trust. This is the thing you want to send important information over, because what TCP does is that it makes sure that the client has the complete information. But UDP here is unreliable. They don't wait to know that the client has the complete package. So why am I bringing this up? Why are we using UDP even? It's very simple. It's just much faster. But why, in what scenarios do we need to use UDP in the sense that we need it to be faster, right? Well, TCP, again, to reiterate, is for when you need to give information to the player and you need to make sure they have this information. So this is, for example, your login credentials, your usernames, whatsoever. These things are important to your players' gameplay. This is information the players need. But UDP, It's the faster one amongst both of them because it cuts down half the waiting time. You don't need to wait for a callback. This is usually used for data that is going to be overwritten the next frame. This is discardable data that you here have this. You don't want it, okay, here's a new one. And you keep spamming that. So when you make FPS games, usually you want to sync data that is done every frame with UDP. And a lot of maybe plugins you guys might use in the future, it might not be called GCP and UDP, it might be using something else, but just know that is reliable and unreliable. Unreliable is just much faster, but the entire purpose of its existence is that you're spamming them. You don't care if they have the correct data because it's going to be overwritten next frame anyway. So little minute differences or imprecise data might not change a lot of things. Any questions? Yes.
If the data from UDP is sent in standard format, that means that only, usually, typically speaking, only the end of the data will be mostly corrupted. Yeah, the first part most likely you will get, but the end part it might be cut off. So that means that some of the data that you'll get, like one part of it will lag, really lag, and the other part will be fine.
Yeah. Yes, exactly. But with network model, basically more structures that we'll talk about later, a lot of these things do happen, but you just don't see it. So again, multiplayer is all about separating what the player sees and what the player don't see. It's all about a smoke screen. It's all about getting the best information out to the player. You are the magician that takes the data, whatever corruption there is, fix it as much as possible, and you give it to the player. All on stage.
Is there a way to not randomize, but send in small packets and like not differentiate, but cycle the data? So one packet you spam it, then second packet you spam it, so that the game will have more or less even amount of data about everything.
Technically, when you use a UDP protocol, it already does that. But in the end, UDP is meant to be short-lived. So when you spam it, you don't expect it to be used again in the next frame. So it doesn't really matter if they already have the data. So maybe in using one frame, you get an X equals 5, second frame goes to 5 million, and then the next frame you get to 5 million. Usually you have a buffer, or a lot of plugins already have this buffer to know that this is abnormal, we just gonna ignore this, right? But if that information is important to you, then you should not be using UDP in the first place. You should just use TCP.
This is calculated, the average amount is calculated on client side, right?
I think, if I'm not wrong, every framework has its own way of differentiating it. But it really depends on how important is that data to you. So, but usually, what gets lost is really replaced so fast that you don't even see it.
Understood.
Yes.
Thank you.
So, any more questions? Yes.
Can a game like this, let's say your bank is stable, can they use both these?
Yes.
Okay, see.
Yeah. You will be using a same combination of both of them in your games. So every data you set, by technical means, it's just defining how your RPC call is going to be set. So it just tells them what format you package it over, or quite simply put, you need to verify that this data is complete. That's it. Yes. Moving on. So this is going to advanced topics. I think we have time for this. So this is what I'm gonna say might blow you guys' minds, or it's gonna signal it, because until now, 3 years of experience, I can't fully, sometimes I don't fully understand it. But we're gonna talk about how games, modern games, optimize on data. So this is, I'm gonna introduce a problem. This is a Boolean. 8 bits, 1 byte. This means true. This means false. Look at all these zeros. really wasted space. But if you use proper, just leave it as a boolean, this is honestly a terrible KPI. This is like 12.5% usage of your entire data. So developers, I guess, of more early games realize that this is a problem. We don't want this. We're wasting space here. So introducing bit shifting. Have anyone heard of this before? Congratulations. Thank you. You're very smart. But see, I have not heard of this and it is magic to me. But when I learned about it, essentially it's playing with, I would say let's play with fire because you're at the, if you don't do it right, you're at the risk of corrupting your own data. But it's also building fire. You are able to control your data and how it's packed. So while I was calling it bit packing, it's technically using a lot of operation called bit shifting because you're packing it into small size of bits. So for example, by using operators, you're able to push bits around into down, which going in is going to from right to left. So it's going down the binary. So technically, if a computer reads it for a boolean, anything that's not a zero is true. So if you move everything down here, convert it to integer, it actually just changes the number itself. Yeah? That's it. Anyone knows binaries here? Yeah? Yeah. So if I push the number 1 here, and then I push another value down, seven positions down, it actually changes it to 102. But if you realize this, I am able to speak another boolean here. I'm sure you guys have touched Unity before. So you guys touched. I don't touch. Okay, I'm trying to be agnostic to engines here. Okay, I do that. I don't touch Unity. So engines sometimes have a big masking ability for you to select multiple flags. For example, a drop down for pick this, and it goes to check. This is called bit masking because technically those are booleans, technically those are bad. It's a smart way of packing all of it into a byte, which is why enums by default are bytes. They can actually fit a lot of data in just using zeros and ones. Which is why we use it as a flag system. If you need to know if, let's say there's 8 booleans here, that means you can fit 8 states in 1 byte. And that's actually a lot of information you can hold. Okay? So let's see an example when we use this to this fullest potential. Boom, that's a lot of stuff. But given this scenario, you need 3 booleans first, then an integer that's guaranteed to be under 32, then another boolean, then another integer that's guaranteed to be under 64, but always positive, right? So that means we just need 3 1 bits, 5 1 bits. So this is a combination that can make up into 0 to 31. It's a combination that can make up 0 to 63. And if we bit pack it, you get that, which is an int 16, integer 16, like 16 bit, then this is 2 bytes. So congratulations, we just fit 12 bytes into 2 bytes. And basically, if you guys ever heard of binary files, yes, this is how it's made. This is exactly how it's made. This is why they're big chunky and you can't read them because no one knows, like the program that reads it or like text for example doesn't know how to unpack that order. So why I say that you can corrupt your data is because the cons of this is you must know exactly how to unpack this data. You are the only one holding the key to unlock this data. It's a specific set of order for you to remove this data out. If you read this by 1 bit difference, you get a complete different set of data. Everything gets corrupted. This is the power of binary. It fits the most amount of data in the least amount of space. You're using literally zeros and ones to complete double data. So pros, much smaller payload. When you send it over, you literally send over an integer most of the time. It can be used as a way to actually do checksum transactions. So I do not have security in my slides, but checksums, basically you want to check if the player is doing something correctly, a certain set of actions correctly, and not cheating their actions. And the server needs to verify this. Very simple. You just send this, the bit packed integer into the server, and then the server just literally just checks if this number equals to this number. Then you will know whether your data is ever modified. If your data is modified, it is a complete different number. This is how you can also use it for verification of your data. So the comment is you absolutely need to know how to serialize this. If you, as the person who packed it in, you need to know how to take it back out, or else your data is gone. So you need to, without prior knowledge, it's basically indecipherable. It's basically same of you guys opening images using a text file. Those bunch of data, binary. So, hey, encryption, security.
Excuse me,
Yes,
I have a question. Regarding the checksum, you mentioned that you use it in games to like, basically verify the player, right? So I have a question. Let's say if on the server, my X position is like, let's say 12.01. Yes. But on my client, it's 12.00999 plus floating points.
Yeah.
Then what happens in this case? The checksum fail, is it checked by integer only?
No, your checksum will be checking your floating point, and floating point is a very interesting problem to solve because floating points cannot be optimized in a way where you really pack the whole floating variable. So that means number one question is why are you packing floating points? Because usually you don't need it. Two, if that number, like that value, is extremely important to you, then you would actually just pack the whole value in. But at that point, no, you do not want to be using float anymore. But floating points, is not for example, but floating points are not, it's a special thing because it's 4 bytes long. So you have 4 bytes, which in front or behind, I forgot where, the bits are actually the value of the position of where the dot is. So in front, right? So the problem here is that you're packing so much data, right? So why not just cramp it all into integers, or maybe truncate it if you can, optimization, and just keep like actually what I'm even saying, you don't really need to. So if you're using floats, right, you're about to lose data anyway, so you don't need to feed pack this.
So, wait, sorry. So by that logic, right, if I were to change my client side data,
Yeah.
let's say I only have authority without position. If I were to change my client side data, and if I were to set maybe one of my any variable, any value of mine,
Yeah.
and like increment it by the littlest bit, because let's say if you're only going to be bit tracking the integers, right, and like ignoring floats, then okay, what are the examples of values that we need to implement a checksum multiplayer games?
So what I know, actually what I've experienced, now that you bring up the question, it's actually a pretty good one because you're actually making me think. We don't ever actually use floats or say anything else. Strings are different because it's a whole other topic, but you need to know how to serialize that. Because strings itself, when it's sent over the internet, it's a very specific format dependent, it's language dependent, which is why strings are dangerous. If you ever code in C++, it's not by default supported because it's not proper representation of data. It's actually I'm summarizing now, it is an array of bytes which are characters, right?
So the problem is with the dynamic sizing.
There is dynamic sizing is not a problem because it's big. You can also put in a header which is telling you what size is this array and what size is this, all this kind of stuff. There's a lot of creative solution for it. But strings, it's different because a lot of platforms, if you're doing multi-platforms, they decipher strings differently. But essentially, when you talk about string, most people just actually turn it into a byte array and then just decipher. They turn it into bytes first. And usually when you use parsers like C# and Unity, right, they actually parse it into byte arrays. When you get like the string parser, serialize it, boom, byte array.
So it's only ASCII supported on UTF-8 or anything like that.
No, it's byte. Whether it's ASCII or UTF, it's based on that. But the cool thing about ASCII or UTF whatsoever is technically supposedly supposed to be standardized and with encodings, right? Once you put it in, there are policies that once you put that character in, it never gets removed. So you have default characters in the ASCII or the whole database. You have default characters and nobody ever uses it because you put it in the policy that you never remove it to form what's it called? What's the point again? Compatibility. Backwards compatibility, exactly. So there's that, but it's up to you if your computer is updated on that. And if not, issue. But most of the time, why I do most of the time this is only a problem for chat servers. And chat servers in a more detailed design, all your games already come with their own string packet. You already know what characters you're using. So if you put in an unknown word, most of the games will show you an unknown word. So again, MMO games, when you see something with a block letter, it's because the game don't support it. They don't support the string. But their keyboard support it. Their PC support it, but your PC might or might not support it. Yeah. So this is about network left and packet loss. I think technically this is a good point. I can give everyone a 5-10 minutes break before I come you guys with more information. Yeah. Let's take this time to like ask you more questions. And I'm gonna drink some water. Sorry.
Yes, please. There's a 10-minute break. You're gonna ask John questions. He's here, but go for it.
So basically for floats, you just cut them down into integers and move it.
Yes. By design, floats are not meant to be reliable. It was never meant to be a reliable way of determining what polling point, like not the text cycling one, but actual like estimate. You use double that. Yeah, doubles of floats because doubles, right? They're essentially integers that are fixed in format and basically the exists somewhere that's fixed. But floats, the dots are dynamic. And this becomes very big problem. That's why the floating precision is an issue. Because if this data might not is unreliable. The dot is dynamic. But with doubles, the dot is fixed there. It's always F. That's the point. And you cannot think of so whatever bits you have in there. Is that what you
But like talking like for real example, like CSGO for example.
Yeah.
What the poetry actually translate percent? Do they just use a long as string of numbers to determine the specific file?
That's a very good question. So technically, you don't need to big packet if you don't need it because if I were a network engineer of CS, number one, I would big pack that data because of the sheer amount of information I need to big pack. So it becomes a problem because you need to serialize it, deserialize it. It's gonna happen every spring like oftentimes, right? Somebody spraying that. I'm gonna cost a lot of my servers. It's gonna take because all that what big packing does is actually not a small payload, but you're offsetting that load to your CPU. You need to serialize it, you need to like encrypt it, right? Excuse me. So number one, I wouldn't big package, there's no point, and it's just causing I'll just take the whole flow that variable over. And technically the trajectory that is scanned, so just specifically CS. Most guns are scanned. So trajectory, you don't sync the trajectory. You just literally get the starting point, regardless. endpoint where it's supposed to hit this event to the player. The player, again, knows that this is the endpoint. The starting points, this is the endpoint. I just draw a frame. Again, small screen. Yeah, so if he does the damage, you already tell the player that he doesn't need the damage.
Like, for example, if it's like 1 point, second point, in some games there's physics like you shoot, yeah, bullet drop,
Yes.
or window.
Yes. So you treat the bullet like a player himself. Just think the bullet. You can see the location, but actually that's not exactly right. You don't have ever even trust the player for this. You actually calculate the trajectory. Give them like a point from let's say, for example, like you start here and you build the trajectory over into here. I know that it's gonna land in like for example 4 seconds. You can calculate how much your return trip is. You set up the points where it needs to absolutely be. You spawn the bullet just teleports, creating a condition and going into trajectory, whereas it's already been given the data that it's going this way. Kind of, but usually this is safe every frame so that they'll avoid any issues.
You know, like when you hold the grenade and it shows you where it's going to land.
Yeah.
Same.
Yeah, or it's the simplest, and this is if you want like happier physics, but the simplest way, just think of it like a physics object that is only in on the server side, and the server that now bring it to be here at this rate. So the grenade just never looks, it just kind of like it just moves like that. Yeah, exactly. Just set the position. So the player ever actually just gets a position of grenade and receives the event and boom exploded. It never actually does the basics. The server does the basics.
You need to write a code that will technically predict that you should.
No, you don't predict anything. The player literally just waits for the information of where the grenade is. The player never actually does anything physics. It's the server that does it. So if you give the player the ability to do physics, and you make the game the based on that location, the player can just make a sheet on there and it just makes the grenade fly somewhere else and pulls up something.
So, then basically the same.
Yeah. So I'll give you a very interesting use case. You guys play the armor tree? Armor tree. Armor. I'm not sure. The armor tree is a very realistic military simulator, right?
Not jumping.
Kind of realistic. Okay, sure. Right. And one thing that was really interesting about they have ballistic physics. That means if you shoot through wood, it will change the trajectory. Just like it. So if you shoot through multiple layers of wood, it actually is like real wood being bent by somewhere else, right? Yeah. Their logic of doing that is very complicated. It's using calculation of calculating. For example, the T here. You calculate this question comes here, and it comes here, comes here, and it goes here. You literally in that one quick scan, you code the entire developers code the whole entire quick scan of going through different layers of materials, and it's not where it is, and literally just over layers how the bullet shows drawn. So guys, it's a type of thing. It's basically bullet reflection. Yeah. Yeah. No stupid question.
Some experience. I have a question related to hardware.
Got it?
Because like, okay, I'm trying to run like a personal server and offer a bunch of much older than this. I was wondering like how much does it actually matter?
It matters a lot. So I just told you that the server calculates the physics, right? That calculation takes hours. You're offsetting. You basically determines the game, and especially if it's physics heavy, it's gonna last an hour. If you're using old computers, that means it's going to be very slow. And if it's very slow, you are experiencing elastic. Depends. Modern servers, like you see that those things technically. Okay, you know GPUs. GPUs are basically extremely strong CPUs meant for one thing to just do graphical stuff. The things servers are actually a fraction of GPUs. That is which is why you have a server, right? Which is why you don't see anything on the server. Because they don't need that. They just need to do computation like so hard. So everything because servers need a lot of computational power to do those things that you mentioned. Which is why it's expensive.
So probably if I were doing all these students.
I guess so, but I guess you can make an array of servers if you want.
No, it's like the idea is that I can basically just try to run this.
Yes, how far is fine. Absolutely. Think of it another computer that make sure things run as it is. If that computer slows down, everyone slows down. Same thing as like peer to peer, same thing as business servers. If that host layers lags, everyone lags.
Okay, probably. I think I can hear you.
Yeah. That,
Mostly, because I think some basic to show example like this.
yeah, sure.
You want to do that thing?
Okay.
Sure. You have to eat for a full break. Thank you.
Professional guys. I'm just waiting for that. Right, so I've been told that this has been 5 minutes, and I should continue on before I forget what I'm supposed to say. I already forgot what I'm supposed to say. Yeah. So next, that's my finger. Yeah. Next, we have network lag and packet loss. So this is the reason why you lost that 1v1 game a long time ago. Sure. So to answer the question of what latency and whatsoever, latency is by definition the round trip time, or basically how long does it get to take the data you sent over to one place and come back. So there's a lot. I feel like there's a lot of descriptions of this because some people define it as how much time it takes for the client to send to the server. Some people define it as client to server then back to client. So it's technically whatever you feel like it. But who cares? It's served for you to debug only, right? Or just tell the player you're lagging. That's it. But most I would define it as the return trip, the time that it comes back to the client. And lag is when your continuous packets receive a delay from sending, and this usually means there is a clog in a network pipeline. There is something yada yada going on. There is rain going on. I don't know enough what caused lag, but yes, you lost that 1v1 because of this. So packet loss, I'm sure you guys have known before, is when you lost data during transmission of your internet. So when you have stuff coming in, so sometimes you see people rubber band packet loss. Sometimes you lost a packet of data for a certain some duration of this. Whoa, something is wrong. People just jump around. Packet loss. And packet jitter is usually a combination of flag and packet loss is when you have and a non-continuous experience with your packets. So these are the terms that you will probably see a lot. And if you're an advanced network engineer, you will have to deal with all of this shit. And let me tell you that you cannot predict this. It's not in your control, but your boss will tell you to take that control away from you. So yes, how do you fight shitty internet?
Agree.
You know, first you monitor network health. This is what I call the ping pong check. I'm not sure what's it called anywhere else. I've never actually went to ask anyone what's the proper name. So I call it a ping pong check because very simple. You ping at a pong. It's a tennis game. It sounds nice. It sounds cute. It sounds severe. So ping pong. The client sends to the server a ping, and the server sends you back a pong. So ping, by definition, is a request. Pong is a response. I'm not going to use those words because they're too long for me. Okay, but basically, you can use the delay from the start of a ping and the end of the pong to determine your latency. So this is why some games call latency as ping. This is where ping came from, I think. I didn't do my research, but hey, so you can do this multiple times per a minute. Actually, this minute is not really defined, but you can do it multiple times per an interval. But it's different with it's subject to the importance of your game. Because what a ping pong does is make sure the most important function of what it does is to make sure that you still have a connection to the server, and the server still knows that you exist. So FPS games, very important. You need to know the player still exists. You need to know the player still is still there. So maybe 2 pings per second. Maybe sim builders, you're building co-op, sim whatever. Maybe 1 ping per 5 seconds, it's not important, right? So it just depends on the importance of the game. So how do we know if a client is connected? This basically using ping pong, right? 2 ways. If a server is expecting pings from a player but isn't receiving anything, we can safely assume that this player has disappeared from the face of the earth. If the client has sent pings but they don't receive pongs, they simply assume that either they don't have connection to the server, or the server is down. Usually, you don't know which one it is. You just say you can't connect the server. So, with this method, the framework is generally already handled by a lot of this is a very basic thing you need to really have in multiplayer. But just to explain more, in every X seconds an interval, you basically send an X amount of pings to a server, and the server sends a response to acknowledge that it's there and you exist, and I know you exist. So the client's role here is to make sure that in the event of them not receiving pongs back in the set amount of time, which a lot of plugins frameworks will call it timeout, you have to disconnect the player. This is where you have to disconnect the player. Realize that okay, the server is the problem at this point. So again, this timeout interval subject to the importance of the game. If not, you're just gonna go in the server where everyone's not moving. So the server's role is to make sure that if it's not receiving pings from a client after it joined in, it times out the player and disconnects the player from their end. It's just to tell the database that this player no longer is in the server, and just for safety, you send to the player again, whether those alive or dead, or not, tell them that you have been kicked, just in case they receive it, just in case that they are able to receive and not be able to get the ping down. So this is a very basic way of monitoring your server health. Next is you smooth out the network blips. So this is also to a question I think Shazar was talking about. Adnan, sorry. Your question about the client authoritative thing, I'm not going to this. This is what I would call actually share like this. So yeah,
That's my boss.
you see, throw a grenade. It's what the element is exploding unnecessarily.
Definitely. Okay.
Boom, and then you die. Yes. So if you guys have ever experienced this, this is basically packet loss or essentially something is not synchronizing properly. And if you realize you saw the explosion there, but somehow they died, right? So that dying is actually a server-sent event to say that, hey, you died from a grenade, but you don't actually see the grenade exploding right where you are. Maybe the server has already detected you throw and hit a wall or something, but you don't actually see them, see the grenade, you see the grenade goes there properly, right? So what is experienced here is actually a form of prediction. So this is a way where we can smooth out network inconsistencies in the game. And this is very important to your experience because not all networks are built to be smooth, especially if your players are in a country that cannot have a smooth internet. This is vital to your proper smooth gameplay experience. So during a very brief packet of network loss meter, you might want to have a mechanic to make sure that the things you see are still consistent a bit for those moments of lack of data. So for example, if the player is going straight here, this is the example of a player walking through a non-straight path forward. You have by popular use cases, you have technically two ways to deal with this. First is the interpolation prediction. This is what happens when you have kind of the end where you need to end data, but you have the starting data, but you don't have the missing packet and you don't know if you're missing a packet. So what this happens is that actually the client side and only the client side predicts that, okay, I know that the direction is going this way, but somehow there is here. Something must have changed in between. So interpolation is a mathematical concept of determining how I can get from point A to point B with a journey. In this way, interpolation prediction basically predicts a path based on the direction and the speed. So this missing second packet, although it doesn't exist, it predicts a path that it needs to curve out. So this is what happens when you see people kind of rubber banding and get snapped back to position. This is your game trying to predict where you're trying to go and getting pulled back on the game itself to go to certain locations. Actually, rubber banding can be also explained by extrapolation prediction. Extrapolation prediction is when you have the starting data, but you do not have an end destination. So even though these two, you use it a lot, you get to sometimes you use interpolation, sometimes you use extrapolation. It really depends on what issues you're facing that you can face, I suppose. So extrapolation prediction happens when you don't know where you're going, but you know the player hasn't finished yet, but you didn't receive a finish line essentially. So if anyone ever got disconnected from games before, that brief moment of seeing everyone run forward and then stopping, that's extrapolation. That is the game trying to make a consistent gameplay experience of people still running around and hopefully get an end packet to continue on that predicted path. If not, that journey, extrapolation, prediction. So Anand, I hope this is part of what you're seeing.
Yeah, I was thinking about interpolation. For the thing that you
But yeah. So interpolation. This is two more popular ways. There are other ways, but I'm not going to talk into that because I can't wrap my head around it. And yes,
Can that be used to like, for example, in CS:GO, you send the packet that you want to go forward, but then cut off the actual movement there. So the game thinks, oh no, you didn't want to go there. I'm not gonna predict you. Snaps you back, and then the person who wanted to shoot you actually shoots the position,
yes,
but you're not there.
yes, that technically is possible. And that technically does happen to people when you lag. When you lag and shoot something that's supposed to be there, and then suddenly they're there and they shot you and you die, that's your computer betraying you because prediction is only done on your end. This only happens when you have terrible internet. Because the prediction is only ever calculated on the client side. It's only what you see. It's not what the player does. So technically, if you're another player, you don't know if they have terrible internet. You can't force them to have terrible internet, I think. But by theory, that's why if you, I suppose, like driving talk around, you can coincidentally meet someone with worse internet and they see you go this way, but you're actually going that way already in the server. Boom, you have basically better protection. For example, also, you play Rainbow Six.
No.
Okay. For Rainbow Six players here, I'm hoping there's one. Good. Do you guys know about Pika's advantage?
Yeah.
Pika's advantage. Because, not exactly this, but it's essentially, when you snap this, the server has to receive the data of you going to this position, but you already see the enemy player there. You shoot them and you go back in. Simple as that. Server receives this, sent to the enemy player. The player sees you moving, it's already starting to interpolate, and you've already died. Because at the same time, you have already died on the server end. This is why this thing is an issue, and this is still an existing issue, and we probably can't solve this until we find it can replace by optics. So lag and interpolation, usually not an issue, and only exploited by very, very, very meta players. Yes.
So my question is right. Sometimes when we as a player see other players lagging, there's two situations. Like sometimes the other players lagging, we still see him move normally, and the other situation is like we can see the player lagging on the 10 or thing like that. So for the first situation where even though he's lagging, and we still see him moving smoothly, is that the collisions doing things?
The effect of you seeing him jumping around is an interpolation, but the effect of him teleporting around is not. And determine it's based on what your game allows the lagging player to do. So, for example, if I am a person who's lagging for like 5 seconds, right, and I move from this point to that point, the server, right, did they receive this data on the internet? If yes, they received it, then technically on your end, you see me jump there because it's just a delayed reaction and the server approved this difference. That's teleportation. And I'm moving here, but you see moving normally, but I walk here and I got brought back. That's because the server rejected me and forced me back here. The interpolation is technically only what you see on other players. And it's also dependent on how the server gives you that data to work with. It's your game trying to work with what the server, your client game, the game they're playing on. They try to work with whatever information is given and how it's trying to give you a smoother experience so that it doesn't look like it's very janky. Yeah, no problem. But I want to point out that in an example of how I say that everything is a smoke screen. By most games and almost every game or every plugin used now, movement is almost always interpolated. Because if I'm syncing, let's say 20 frames a second, you will see, and we're not using interpolation, you will see me teleport. Because my game runs 60 FPS, but I'm syncing 20 frames per second. You got to see the player teleport like animation frames. So what happens is actually interpolation. Between these two points, you're interpolating an animation and using extrapolation to determine that it's going this way, kind of, and then you're interpolating between your movements. So you don't really see it. It's like the illusion of animation. It's actually all still frames, but move fast enough, you don't see the difference. So the interpolation mechanic is just used in this very subtle way to give you a very smooth experience. The things that actually moves and sync in the game, most likely all of that uses interpolation. If not, you're gonna absolutely see that boop, 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 boop. Yes, if you guys actually had a chance to work on your own multiplayer game, turn off interpolation and see how laggy it gets. You will see it's a very, very jarring experience of your players teleporting around, especially it's not consistent. Yes. Any other questions? Okay. Right. So ultimately, you can't fix her, guys. You have to send them to therapy. So you cannot fix bad internet. You cannot fix any intervention from God or undersea peoples. So hopefully, by properly designing your project architect, you will lead to the third rule of multiplayer club. Design the game like a full stack dev. Anyone here is a full stack? Loser. Right. So making a game is like you're building a software engineer. There's front end and back end is what I was talking about smoke screen and stuff. So if you're a game developer, you are absolutely needed to do this regardless because there's UI as well, which works the same way. But unlike a software engineer, you only take 30% of their salary. Loser. Touche. So welcome to the industry. If you're here to look for money, wrong industry, guys. Absolutely wrong industry. So your server and subsystems, whatever backend that the player don't see, does all the important work of making sure the data is there where it needs to be, and making sure the data is properly set up for the players to work with. Your visual actors, anything, your meshes, your game object, your actors, whatever you use to show the player actually just needs to exist there. Because whatever you're doing is always a puppet show. In multiplayer game, I say it again, it's a smoke screen. You have all the data, you build a system to work with all this data. It's your actors, the things you show, tries to smooth out all the blips and just exist where they need to be. So think of it like a front end, think of it like a back end. So this combination makes a multiplayer game. Yes. So if you think of a very two-layer design, the server is always this loop per frame. The server first processes your very important game logic, your game state, or anything that needs to happen for the game itself. The client it sends the information to the client, and the client backend processes all this incoming data. This means that okay, player needs to teleport here. I first change the data and log in the data to this place. We move all these places and make sure the conditions are set up correctly. Then we only tell the front end, the VFX, whatever it is that the player sees to do those things. So never break this cycle because if you break it, you're gonna have a lot of issues, and you will realize that water flows down the river one way and not the other way for a reason. So even if you're asking for change, you see the side request like go here, you're actually deferring it or basically passing it to the next frame or send it back upstream. So data only goes from top to bottom, in this case left to right. So we have to manage incoming player connections. And when there's a lot of players, it's going to be a lot of issues. So instead of managing all players' connections together in one single session and figure out what players are playing together, it's going to be a lot of issues. We break it into a room system, which is actually a very, very popular system that we use in almost every game, which is what we call matches, which is what we call sessions. Whatever game it is, I call it a room system because you guys are just having a party in a room together. That's why it's called a party. But you see here, it's an example because multiple players in one group itself. Oh wait, is everyone playing the game? Is everyone in the room actually like doing stuff together? So maybe you do not want that. We can create a lobby system to first pull all the players in one location before actually setting up into parties. This is what you get, what you call, that's called a lobby. But every game has, for example, Apex Legends, you learn the lobby, you create a party first before you go into an actual game. A lot of multiplayer games are Call of Duty, I suppose. You can chat to other players, but you can't actually move your players, move your character, right? this is a lobby system where, in a concept where you want the players to be able to interact with each other in a very limited capacity, group up together before actually giving them rooms, because creating rooms takes computing power, takes managing connections, takes power to manage connections, and henceforth you want to limit that as much as possible. So if you have someone that isn't actually playing the game and is idling, you don't want them to be using a computer power. You don't want to be synchronizing their data. If they're not playing a game, kick them out, whatever. This is where you create a lobby, and if they are okay with their friends, they go into the room. And see this line here, this is where you can put your matchmaking system. This is where you can pair people up to go into rooms and have fun with each other on this wall. Yeah, but how do you avoid a server from overloading? So, ever heard of a DDoS attack? So, a DDoS attack is when a server or somewhere, a computer, suddenly handles a lot of requests, again, keywords from somewhere. And the server will try to deal with all these requests and send the response out, but in that case, severely slowing down because they're handling way too much data. So imagine all these players are joining, let's say we have 100 players, 60 frames a second. I guess you think, let's say 30 frames a second, 3,000 requests a second. You have multiple rooms of 100 players. 5 rooms, sorry, you have 15,000 requests per second. If your server can handle that, your server is going to lag a lot. And this is true for a lot of not only game servers, or like any other server out there. You're handling a lot of connections. You need to know how to break down your servers and avoid the server overload, which is why servers crash. By the way, if you have too much, the DDoS attack can crash the servers. Is why people carry out DDoS attacks. So technically, a client can connect multiple servers. They can cheat on their one only server and make connections to other servers themselves. And each of the server can actually be tasked to handle the different things. So this decentralizes what a game server can do, and basically delegates out different tasks to different servers to specialize and handle different things. So I want to give an example on the unnamed project that I have, AAA. Actually, we have one client next to 1, 2, 3, 4, 4 servers, but there's actually 5 servers in play. One client, 5 servers to handle this. Anyone who play games will have seen the chat. Has ever used chat? Almost exclusively has a chat server itself. So if you guys have played Warframe, if you accidentally see that chat server disconnect, this is why it happens. So at any case, if your server dies, it doesn't kill the game. So the most important server you keep alive is the game server itself. So just make sure the game server is well protected. Anything else is just extra stuff, extra services you can load up. So in our game, in my game, we have the chat server that handles chat. The database will handle connections, get player data and whatsoever. A UGC or content, player made contents whatsoever. And connect to the game where you actually synchronize all players and whatever happens in the game. All this one thing, and the game actually synchronizes to the virtual assistant server, which is damning evidence that I'm breaking my NDA. So yeah. Oh shit, that's recording. Okay. But yes, defer your server if you can. So yeah, I have reached faster than I thought. I should have put in my security section in. Did all too fast. So before actually I'm just gonna go through this. My final advices for all you fledgling multiplayer engineers. And hopefully you guys don't take the trial of fire and don't die at the end. But yes. Number 1, don't jump your request handlers because it is going to be extremely muddy if you jump them. So if you have an object that goes through a manager and the manager can handles all the requests to the server, do not let your object request directly to the server. This is one thing I see amateur multiplayer engineers do. is that there one single actor tells the server, hey, I want to do this. And then your manager says, hey, this object going to do this. And then you got a missing problem. You're laughing, so obviously you did it. Yes. Do not do this. If you want to standardize and make sure everyone is standardized to this, do not ever jump. Number two, you have to think multiplayer from the start. Okay? When you build a game, like even whatever projects I'm handling now, there's absolutely NDA. Think about multiplayer from the start because actually a lot of game design and a lot of game implementation would revolve around the need of replicating your entire game. So there's a lot of data that you don't actually expect yourself you need to replicate that end up yourself will replicate unless you're very, very experienced. Even I am caught off guard by a lot of things. And this is an advice I can give is think multiplayer from the start. Hydrate, don't wait, strict multiplayer. Right. Think of quality assurance tests. QA your game. If you think single player games, it's very hard to QA. If you're making a 4-player game, you need 4 players simultaneously to play the game. You never know if something will break on the 4th player, or the 3rd player, or the 2nd player, or the 2nd player, and then someone else joins in. Yeah. So for every player you're allowing to play in a game, it is one test scenario factorial downwards for your quality assurance. So that means if you're making a 100-player game, you need 100 factorial situations, permutations to make sure your game is running smoothly, which is why Fortnite, 100 players, I think.
Yeah.
Their QA team is extremely huge because they need to be on and to play. When I built my project, we hired 3 companies to test out the game. And that's a lot of money there to make sure it runs right. And this is absolutely separate from normal other QA tests, like speed tests or whatsoever. So if you're dealing with no budget, make sure your teammates are awake at the same time as you do, and do not do it like me at 5 a.m. I think that's the game of me. Yes, make a cheat system. Cheat is bad, but cheats are basically God's tool for developers, which is why it's called developer tools. Because if you don't do this, I guarantee you'll be shooting yourself in the foot. You have no idea how some things can take a lot of time to set up. If you can think of a cheat system early, so that your testing will not be a pain in the ass. Yes. Handle your disconnects. This is also from my feedback and experience is when players don't get disconnected properly, whether intentionally disconnecting or something went wrong, they're gonna get very, 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 very frustrated. And especially you're actually selling a game, they're going to be very unkind about it. Make sure when they are, I said, oh, I think I'm the slide for graceful disconnections. Graceful disconnections is when it's voluntary. And graceful disconnections when it's involuntary. Make sure those are handled properly because, and on both ends, because if your server thinks you're already logged in and the guy has already disconnected and comes back in, you're gonna have a replication issue. You have a distinct issue and an overriding issue. Make sure your disconnects are absolutely handled correctly because your connections, the gateway should only ever have one existing. If not, it's a doppelganger and it's gonna ruin your entire life. Yes, have a T-shaped team in networking. If you're building a game, make sure your team knows how to build a basic knowledge of networking. I cannot count the time of someone pushing something that absolutely breaks the game and doesn't replicate, and I'm tells me, ask me why, and then I have to do that stuff and realize that I redo it again. Make sure the team knows the basic knowledge. You don't have to know how to replicate it, but you need to know what needs to be replicated. They need to know what, like health, for example, like any important data, it needs to be properly set up for replication. If they did it only for local side, like client, they trust the client, boom, issue, hackable game. But as a T-shape, you need someone who's actually in charge of that itself. So the guy can actually solve problems. It's not no one else solve. Do it like Paul. Technically, that is all, folks. But 5 minutes back. Okay. technically, I obeyed the time, so yeah. Wow. Yeah. So, if you guys have any questions, just hit me here. Or, come on, yeah, so that's blue sky. Um, oh shit, yeah. So you can find me on LinkedIn, that's my professional side. If you want a professional answer, LinkedIn. If you want father, that's me there. If you want blue sky and Elon support Elon Musk, it's me there. What the fuck? Discord, you can ping me. I think it's the most reachable of me. It's Discord. Yeah. But send me a message. If not, I don't know who you are. I will reply. And that's my website for whatever reasons if you want to hire me. And yeah, make me popular. Guys, Q&A, but I thought I asked John some final questions. Except for that guy.
This is FYP question.
Okay, FRP good.
So for our FYP, we're planning to do a peer-to-peer game. And we plan to like continue it to Steam. The question is, so we need the Steamworks API, right?
Yeah, that's why I said good luck.
Yeah, yeah. So we have to start with that in mind, correct? Like we have to start using it. We can't switch because
This question is basically, you're basically asking if, hey, I'm building a game and I'm deploying it to Steam and only dependent on Steam's server system. So if that's yes, and you're confirmed on doing that, then yes, of course, put that in mind, because all APIs are absolutely different. For example, if you, I'm not quite sure about this, but if you only publish or do a deal with Epic Games, you can use their server for free. And that is a whole different API as well. I'm not 100% sure if I'm sharing something and break NDAs, so it's going to be very big. Steam has their own way of building stuff, and it's maybe much more flexible for different systems to liaise with it or like in it. Epic Games maybe not, it's built much more for Unreal Engine. So it depends on what you need, what you want, or what engine you build on. Just, if you're very sure of where you're going to deploy, then yes, absolutely keep it in mind. But just know that if you pivot later down the road, if you're not giving it flexibility, it's going to cost a lot more time. You know, you're basically setting down, you're locking in.
yeah. So for Steam, I heard we can't like test it outside of Steam since it's using the Steamworks API, and Steam like takes the $100 from you so you can upload your game. So do we have to like put that down so we can test the game if we're using Steamworks API?
Maybe I should push this in there.
No, we haven't started. So do we have to push it to Steam so we can test it using the Steamworks API?
It's the default one, right? The default server, the one is like the, I don't know, but that's the default one, so. You don't need to push it to the main server to test.
No, no, I mean for like, yeah, yeah, like I saw developers that like test their games on Steam. It's usually space for test the developer tools and stuff. So do I have to like push it to Steam and pay the 100 to test the game?
My recommendation is for this. Because just doing FRP like student, right? I think you're overschooling. Because you are like putting out money to do this kind of stuff really. Is it your first one doing?
Yes.
Yeah.
Because technically I'm doing multiplayer internship. So technically,
You can if you want because I'm not sure if it's changed since Steam Greenlight. I know you need to like basically buy a store which was basically $100, right? And it's all money. And that's also if they allow you to actually publish use the server. And I'm not sure if the server authority or like permissions already changed, but they can also reject you from using it. So what happens if you pay and they reject you from using because you're an incomplete game? Are you gonna go past your FYP timeframe and complete that game before you test?
Okay, but can we, like, if we, do you know how long they usually take to
No.
like that? Okay. What would you say is the best multiplayer solution in Unity? Like, I saw Fishy Steamworks, Fishnet, Mirror, Network, Bottom.
I would say
It's a two-player co-op game.
it must be through a server.
No,
Actually,
we want
wait a
to
minute.
do peer-to-peer.
I just thought about it. If you're using peer-to-peer, why are you using servers?
No, I don't want servers.
Okay, so you're using streams distribution for what exactly again?
So we want peer-to-peer, but like, I saw Lethal Company, which is made by an indie developer as well.
Yeah.
They're using peer-to-peer, and I saw they use Fishy Steamworks as their base for multiplayer, which is Fishnet using Steamworks API.
Personally, I recommend if unless you're absolutely confident you can handle Steam's API, I'd say the reason why you've been using it is just the easy access of connecting to friends and playing with friends using the Steam friends system.
Yeah.
And if you don't need that, you can use the old way of doing P2P or listen servers in the sense that you know how like you can give a code and room code into the player and you play that. That's one way to do it. For on FYP, I also we did this not really a listen server, but it's kind of it's weird, but we also did the same way, kind of listen server, we give a code out. And how that works is the reason why we need this is because we need a lobby system in the first place, which is why you need a server. The lobby system is the server itself, but connect them to matchmake with other people. If not, through peer-to-peer or through listen servers, need to directly connect to their IP. This is where port forwarding happens. This is if anyone who has built a Minecraft server and port forward them and basically expose their Wi-Fi for attacks.
Oh my God.
Yeah.
Yeah, I've done port forwarding, but for example, when I released this as like our first indie, like truly indie project.
Yeah.
So we want it to be accessible for everyone. Don't want people to like go through that sort of port forwarding or whatever. So that's why I was thinking like Steam. It's the most accessible. You can host, like it's running on them. The player doesn't really have to do anything.
Okay. And that's your heading to your business strategy. So using Steam is also part of your business strategy. So that's something I can't say for you. So that's up to you to determine how much value is there in the business strategy for you to be using Steam's API to provide accessibility for a place.
Is there any other way to do peer-to-peer without?
So, I mean, you can use a lot of plugins. Photon does that, Mirror does that.
Yeah, I saw Photon, but Photon is, I think if it goes past the limit, it becomes quite expensive.
Everything has a cost.
Yeah.
Same thing. So it's just whether you're confident enough, you just go and get your from it. There's a lot of ways to do it. So if Steam is what you think you're confident doing it, just go ahead with it. Because all of that cost might not be monetary. Right? So if you're confident, just go ahead.
So would a peer-to-peer game on Steam cost you anything past $100?
I don't think so. You just want to solve it cheap. You just need to survive it, I suppose. I don't know enough to this story.
Oh, last thing. Yeah, going back, did you use any Steamworks API in Unity? Any like,
I just said already. Already.
oh, Unreal Engine?
Yeah, sorry, not really. So for Unity, my experience is building my own server using Unity. And not that for the lower end. The lower, it's called network something. It's what netcode you build upon.
Unit?
Yeah.
Yeah, that's like what is now deprecated like this.
Oh, yeah. Sorry, that was before anyone has any other questions.
Yes. Not, you can always find me there, or you can find me here, or you can stop me somewhere. Yeah.
So all this layer is picture life. So at which point of your redevelopment career or skills that you think that it's about time that you can start going into this topic again? How do you know it's the right time?
I know it's the right time for me to start making games. It's the same thing of any other thing. Multiplayer is hard, making games is hard, making anything hard and it's hard to skill. What is hard is just overcoming that fear of going into the unknown. Because no matter where you go, no matter where you spend your life, you're gonna hit a lot of things you absolutely do not know. And a lot of what keeps people from going into this is they're not comfortable with being surrounded with absolutely nothing. Feedback on you don't know what you don't know, right? So if you have the space, time, and the flexibility to fail in a safe space, go ahead and do it. Because I got my chance, and I think I got my chance, and I flourished from there. And my career continues to help me build upon with those experiences. Okay. So I guess that's about it. So give John a round of applause. So that is the wrap of our their talk. I'm just gonna go through some of our upcoming events, do a little bit of speak list promotion, and then we'll do a photograph session, and I think that we're good to go. So first of all, please follow us on Instagram, PPTVC, if you haven't. We need our follower count to go up. So please follow us. Next slide. Now let's talk about our upcoming events. We have three fire step display upcoming workshop talk is coming soon. Remember, this is very early registration form. So you guys are getting like pre-order registration. Since this is not out yet, if you guys want to sign up, they can do right now. But they will also do an official announcement on Discord, Instagram, and other socials basically. And also, we are having a game night with UOW on 4th of November. So this is a talk. I mean, it's like a game night. You can go to UOW and play board games with UOW. Go there, make new friends. For more information, if you want to secure transportation, we are providing transportation from ATU to UOW, but make sure to go to Discord to get more information. Something of course, please secure us spots, and that's about it. So everybody,
What is your W?
I have no idea what's your number. Also, one more thing, we must have a good dog workshop and speaking as a UOW University of Hong. Also, we will have a good dog workshop in December. Please make your schedule free. I'll be hosting it, so please make it anything. Thank you. I want everybody to move to the center. Please move to the center. We want the handsome guy to be at the middle.